Okay, so we talked a little bit about liquids. Let's talk about some solids. We have several different types of solids. So the first one we're going to talk about are crystals or crystalline solids, where we have a regular repeating pattern. Here is an example of one. This would represent sodium chloride, the sodium being the silver, and the chloride being the green. And it could also represent anything with a 1-to-1 ratio. And we get a crystal lattice, a repeating pattern. We have all sorts of different types of unit cell. This particular one is cubic, and that gives us all of our different crystal shapes. Now we can determine the structure with something called X-ray diffraction. That is the way beams of light are scattered by the crystal. And we do that with our Bragg equation. N, the integral number of wavelengths, lambda wavelength, d, distance between planes of atoms, and theta, the angle of reflection. So those two, wavelength and distance between planes, those need to be in the same unit. But we could use nanometers, picometers, angstroms, and we could put them all in meters. It doesn't matter as long as those two are the same. So let's look at our example here. We have a lambda of 154 picometers. We have an angle of 14.22 degrees. We have first order diffraction, so that means 1. And d is what we want to find. So let's take our equation. And we need to get d by itself. So let's rearrange it right away. So we have 1 times 154 picometers divided by 2 times the sine of 14.22 degrees. Make sure your calculator is set for degrees, not radians. So let's calculate this. Or maybe not. There it goes. Okay. So, all right, it apparently does not want me to do that. So we have 154 divided by 2 divided by sine of 14.22, and that gives us 313. Where did my stuff go? Well, that's odd. But we get 3. Oh, there it is. Nothing like some entertainment in your video. So we have 313, and the unit is going to be picometers, just like our wavelength. Now we can have different types of crystalline solids. We can have atomic solids, which would be just a single atom. So those can be metallic, network, or group 8A, which are the noble gases. We can have molecular solids, and we can have ionic solids.